Hi everyone, this is Pratima Naik. Today we will develop the concept of three-dimensional geometry, equation to a plane. Plane needs a support to be in space. Plane needs a perpendicular vector or normal vector from the origin. When we talk about plane, we need its normal vector. First, to get equation of a plane, we'll get vector equation to a plane when normal vector to the plane and its distance from the origin is given. Let us derive the equation. Now let OP is equal to small d distance from the origin. Then OP vector, if it is denoted by n vector, this will be equal to d multiplies n cap when n cap is the unit vector along the direction of OP vector. Let R be arbitrary point on the plane. Then OR vector represents the equation to the plane because it is the locus of the points on the plane. So OR vector is equal to OP vector plus PR vector. Now PR vector is equal to OR vector minus OP vector. So PR vector is equal to R vector minus DN cap vector. PR vector is perpendicular to OP vector. So PR vector dot OP vector is equal to 0. Or we can write PR vector dot n cap is equal to 0. Now replacing PR vector by R vector minus d n cap vector dot n cap vector is equal to 0. Now multiplying R vector dot n cap vector minus d vector n cap dot n cap is equal to 0. So we reached in the equation R vector dot n cap vector is equal to d. So this is the vector equation to the plane. Something more to know about the distance from the origin. Now let us take an example. R dot 2i cap plus 6j cap plus 3k cap is equal to 7. Now is it an equation to a plane? If it is, what is the distance from origin and what is the normal vector? Yes, it is an equation to a plane because it is in form of R vector dot n vector is equal to d. But d here 7 is not the distance from origin because 2i cap plus 6j cap plus 3k cap is not a unit vector. So first, to bring it to in the proper form or standard form, we have to convert n vector into unit vector. So it is 2i vector plus 6j vector plus 3k vector by magnitude of the vector, that is 7. So dividing throughout by 7, we get R dot 2ik plus 6jk plus 3k cap upon 7 is equal to 7 by 7, 1 on the right side. So distance from the origin is 1 unit. Next we will learn to convert vector equation into Cartesian equation to a plane. So if the vector is R vector dot AI cap plus BJ cap plus CK cap is equal to small d, then here the R vector is the arbitrary vector is always denoted by xi vector plus yj vector plus zk vector. Now just replacing our vector by this, we'll get xik plus yjk plus zk cap dot aik plus bjk plus ck cap is equal to d. So you know the scalar product, it will be a into x plus b into y plus c into z is equal to d. Now a, b, c are called direction ratio of the normal vector to the plane, and ax plus by plus cz is equal to d represent the Cartesian equation, but please note d is not its distance from origin unless it is a normal vector. It is a unit normal vector, sorry. So Lmn a direction cosine of the vector, then Lx plus My plus Mz is equal to d, where d is the distance from the origin because Lmn are the direction ratio of the unit normal vector. I hope you understood. Now we'll get vector equation to a plane in scalar product form. Now if a point is given through which the plane is passing, that is denoted by vector A, and plane is perpendicular to normal vector n vector. So now OA vector is equal to vector A. OP vector is equal to vector R. So AP vector is equal to R vector minus A vector. AP vector is perpendicular to normal vector. So AP vector dot n vector is equal to 0. Now replacing AP vector by R vector minus A vector, we get R vector minus A vector whole dot n vector is equal to 0. So this is the vector equation to a plane in scalar product form. Next we will learn to write Cartesian equation to a plane in scalar product form. The plane is passing through a fixed point whose coordinates is x1, y1, z1 and direction ratio of the normal are a, b, c respectively. Now AP is perpendicular to the normal. Normal is the direction ratio a, b, c. AP has direction ratio x minus x1, y minus y1 and z minus z1. So since they are perpendicular to each other, so a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. So this is the Cartesian equation to the plane when one given point is there and normal is there. Now we will get the vector equation of a plane passing through three non-collinear given points whose position vectors are vector A, vector B and vector C respectively. So OA vector is equal to A vector, OB vector is represented by B vector and OC vector is represented by C vector when O is origin. Now let us take a OP variable vector on the plane. So let it represent by R vector. So AP vector is equal to R vector minus A vector. AB vector is equal to B vector minus A vector and AC vector is equal to C vector minus A vector. And here AP vector, AB vector and AC vector are coplanar. So their scalar triple product is 0. So AP vector dot AB vector cross AC vector is equal to 0. Now putting them in term of R, we will write R vector minus A vector dot b vector minus a vector whole cross c vector minus a vector is equal to 0. So this is vector form of equation passing through three non-collinear points. Now same 3 points are given as a x1 y1 z1, b x2 y2 z2 and c x3 y3 z3. We will find the Cartesian form of equation passing through these three given non-collinear points. Now we already know AP vector, AB vector and AC vector are coplanar, so their scalar triple product is 0, and we have already seen that this is r vector minus a vector dot b vector minus a vector cross c vector minus a vector is equal to 0. Now taking P point as x comma y comma z, a arbitrary point, we will get direction ratio of APs is x minus x1, y minus y1 and z minus z1. Similarly, direction ratios of AB x2 minus x1, y2 minus y1 and z2 minus z1. Direction ratio of AC x3 minus x1, y3 minus y1 and z3 minus z1. Now we will put this scalar triple product in determinant. So in determinant, first row will be x minus x1, y minus y1, z minus z1. Second will be x2 minus x1, y2 minus y1 and z2 minus z1. Third will be x3 minus x1, y3 minus y1 and z3 minus z1 is equal to 0. So this is the Cartesian form of equation, the plane passing through three given points. We will find equation to a plane when their intercepts are given on axes as A, B and C. So the plane is passing through the point A whose coordinates are A, 0, 0 and it is passing through B whose coordinate is 0, B, 0 and it is passing through coordinate C whose coordinates are 0, 0, C. So direction of ratios of AP, the x minus a, y minus 0 and z minus 0. Direction ratios of AB, 0 minus a, b minus 0 and 0 minus 0. And direction ratios of AC, 0 minus a, 0 minus 0 and c minus 0. By putting in them in determinant, we will get x minus a, y minus 0, z minus 0, 0 minus a, b minus 0, 0 minus 0, 0 minus 0, 0 minus 0, c minus 0 is equal to 0. Now if we simplify this and you will write in a proper form, it will be x upon a plus y upon b plus z upon c is equal to 1 when a, b, c are intercepts on axes. Next concept is angle between two planes. Now angle between two planes is the same as angle between their normals. If two planes are given as r vector dot n1 vector is equal to d1 and r vector dot n2 vector dot is equal to d2, then angle between them is defined by cos theta is equal to n1 vector dot n2 vector over magnitude of the n1 vector multiplication magnitude of the n2 vector. Similarly, if two planes are given in Cartesian form, first is a1x plus b1y plus c1z is equal to d1 and a2x plus b2y plus c2z is equal to d2, then cos theta is equal to a1 into a2 plus b1 into b2 plus c1 into c2 over and square root a1 square plus b1 square plus c1 square into under root a2 square plus b2 square plus c2 square. So next concept is angle between a line and a plane. If theta is angle between a plane and a line, then angle between normal of the plane and b vector of the line is 90 degree minus theta. So r vector dot n vector is equal to d is the plane and line is r vector is equal to a vector plus lambda into b vector. Then theta angle between them is defined by cos 90 minus theta is equal to n vector dot b vector over magnitude of the n vector and magnitude of the b vector. Or we can write directly, it is sin theta is equal to b vector dot n vector over magnitude of the n vector into magnitude of the b vector. Next, equation of a plane passing through the line of intersection of two given planes. So first we should have the concept that infinite number of planes can be passed through the line of intersection of two given planes. So let us write the vector equation of the family of the planes passing through the line of intersection of two given planes. R vector dot n1 vector plus d1 is 0 and r vector dot n2 vector plus d2 is equal to 0 is simply r vector dot n1 vector plus d1 plus lambda into r vector dot n2 vector plus g2 is equal to 0. So this represents the vector equation of the infinite number of planes. Similarly, if two planes are given in Cartesian form, then we can write the Cartesian equation of the plane passing through the given plane line of intersection a1x plus b1y plus c1z plus d1 is equal to 0 and a2x plus b2y plus c2z plus d2 is 0 is equal to a1x plus b1y plus c1z plus d1 plus lambda into a2x plus b2y plus c2z plus d2 is equal to 0. Now given the general equation to family of planes, but when we want the equation to a particular plane, other references are required. It may be it is passing through a given point, may be perpendicular to a given plane, may be parallel to a given line, or it may be given the distance from the origin. Then only we can find the equation to a particular plane. Next concept is distance from a given point to a given plane. Distance from a plane r vector dot n vector is equal to d from a point whose position vector is vector a. It is simply modulus a vector dot n vector minus d upon magnitude of the n vector. If it is given in the Cartesian form, distance of a plane ax plus by plus cz plus d is equal to 0 from a point x1, y1, z1, the distance will be ax1 plus by1 plus cz1 plus d upon square root a square plus b square plus c square. Now, if the question is from distance from a point on the plane from origin, then it will be x1, y1, z1 will be 0, so it will be simply d upon over square root a square plus b square plus c square. Thank you for watching. I hope you have enjoyed, you have learned something. So please share, subscribe so that others can learn.